Here's another one to try. So let's get it in matrix form first. That will give me 2, -3, -1, and 3, -2, 1. Our first objective will be to get this to be a 1. And the way I'm going to do that is, in place of this row 1, I'm going to take row 2 and subtract row 1. So row 2 is going to stay the same, and row 1 will become 3 minus 2, or 1, -2 minus -3 will also be 1, and 1 minus -1 will be 2. Now that I have this 1, I'm going to use this row to make a 0 down here. So I'm going to take row 2 and I'm going to subtract 3 row 1s. So row 1 will stay the same. Row 3 minus 3 times 1 will be 0. -2 minus 3 times 1 will be -5. And 1 minus 3 times 2 will also be -5. Again, I'm going to recopy just so we don't lose any steps. So all I'm doing for this step right here is recopying my end matrix from the first row. Now I want a 1 here, so I'm going to take row 2 and divide it by -5. Row 1 will stay the same. Row 2 will become 0 divided by -5 is 0, -5 divided by -5 is 1, and again a 1. Now I can use this 1 in row 2 to get my 0 up here, and to do that I'm going to take row 1 and subtract row 2. So row 2 will stay the same, and I will take 1 minus 0, so give me 1. 1 minus 1 will give me 0, and 2 minus 1 will give me 1. This ordered pair then becomes x is 1, y is 1, and again it is an independent system. Now we'll try Gaussian elimination with a system of 3 equations. So starting my augmented matrix, I'll have 1, -1, 1, 2, -1, 1, 1, 4, -1, 0 for the y since it's missing 1 and 2. First thing, I needed a 1 in the first row, first column. I've got it. So I'm going to start right away with getting the zeros here. So I'm going to take row 2 and I'm going to add row 1 since 1 plus -1 will give me that 0 I need. Row 1 will stay the same. Make sure you pay attention to the signs. 1 plus -1 is 0. 1 plus -1 is 0. 1 plus 1 is 2. And 2 plus 4 is 6. Now, many textbooks will do another step, copy row 3 here and do another step. I like to save paper and time. So I'm going to take row 3 and add row 1 also, since that will also give me the 0. So 1 plus -1 is 0. -1 plus 1 is -1. 1 plus 1 is 2. And 2 plus 2 is 4. My next step, I notice I have this -1 here and a 0. Well, 0 is what I need in the bottom row here, and I need a 1 here. So I'm going to trade row 2 and row 3. I'm really going to trade row 2 and row 3. So row 1 stays the same. Row 2 and row 3 trade places. And the next thing I'm going to do is take my new row 2 times -1 so that I can end up with a +1 in that column, row 2, column 2 position. So that will give me 0, +1, -2, and -4. And then the bottom row will be 0, 0, 2, and 6. Now I need to use the row 2 to get a 0 in row 1. I've already got the 0 in row 2. So I'm going to take row 1 plus row 2. Row 2 is going to stay the same. So 0 plus 1 is 1. 1 plus -1 is 0. -2 plus 1 is -1. And -4 plus 2 is -2. And, oh, look. Next thing I would need is a 0. I'm going to take row 3 and divide it by 2 since it's not going to bother the other rows. 0, 1, and 3. So now I'm ready to use this 1 to make the zeros here. So I'm going to take row 1 plus row 3. Get my 0. Row 3 is going to stay the same. Um, 0 plus 1 is 1. 0 plus 0 is 0. 1 plus -1 is 0. And 3 plus -2 is 1. And then I need to get a 0 here, so I'm going to take row 2. I'm going to add 2 row 3's. Well, first two numbers in row 3 are zeros, so they won't change row 2. -2 plus 2 will be 0. -4 plus 6 will be 2. So I have my diagonal matrix, my reduced echelon matrix, and I can find out that x is 1, y is 2, z is 3. And that ordered pair is my solution to the system of equations.